All right, let's get started. So, exercise 10A, 10B are the ones we're covering. We're going to be covering tangents and normal. Theoretically, you can already do this. It's pretty straightforward in the sense that how do you find the tangent line? So in this example here, I've got a quadratic graph and I've got a blue line or straight line, which is a tangent line at one single point. Okay, so it touches the curve once, exactly at 3, 9. So that means at x equals to 3, I want to know what the gradient of that line is. So using 1 point, I want to know the gradient of that point is. That's what chapter 9 was. Chapter 9, you were going through all the skills. Instead of doing first principles, you learned all the rules to find the gradient of 1 point. And that literally was this one. The gradient is the gradient of the straight line. That straight line is called a tangent line. But you only used a single point. That's the m you're trying to find. So it means that in this question, when they say find the equation of the tangent line, you're already 50% of the way there. Because you would find this through derivatives. And you're only missing c. And that's what the first exercise is. The exercise is for you to put them all together to find the straight line equation. So you just need to remember every time you differentiate at a particular single point, you're actually finding just the gradient of a tangent line. So here's an example. Let's calculate the equation of the tangent line at 3, 9 for the curve y equals x squared. So what's in red is the y equals x squared. Specifically at 3, 9, I want to know the gradient of the tangent line. So here we go. To find the y equals mx plus c, the equation of a tangent line, I know that m is the gradient, which we can find by delta y delta x. Because that is delta y delta x at a single point. Here we go. Y equals x squared, so delta y delta x must equal to what? This is power rule. Let's go with Erwin. What's derivative of x squared? 2x. So that means we know this will tell us the gradient. But at which point am I looking at? Let's go with, what have I chosen for a while? Let's go with Vibha. So I want to find the gradient of the tangent line at 3, 9, the curve, y equals x squared. Derivative is 2x. But I want to know the gradient at 3, 9. So what is... Good. What am I subbing in? 3. Very good. Not the 9. It is here. It is when x equals to 3. That is the gradient that I'm looking for. I'm looking for at x equals to 3. So here at x equals to 3, just like Vibha said, sub it in. Delta y delta x, which tells you the gradient, it's 2 times x, which is 3. 2 times 3 is 6. That means you now know the gradient of this line, y equals mx plus c, it must be 6x plus c. That's what you've been doing. Every derivative that you've been doing in chapter 9, finding it at a particular point, or they call it instantaneous rate of change, that's what you were finding, just at m value. The only missing part was c. Now to find c, back to year 9 maths, literally up to this step. This is year 9 maths. See, back in year 9, you had to do y2 minus y1, x2 minus x1 to find m, which you needed 2 points. Now you don't. You only need 1 point. You found m. How do you find c? Aryan, do you remember? What can I do now? With the information I've got, how am I going to find c? Very good. I sub in 3, 9, sub in a point. Because I already got an x, and I already got a y. I know that when x is 3, the y coordinate's meant to equal to 9. So therefore, this is 9 equals to 6 times 3 plus c, and I can solve for c now. That's 18, 9 plus c, therefore c must equal to 9 minus 18, negative 9. That gives us, therefore, y is equal to 6x minus 9. This is the equation of your tangent line. And that's why the theory is powerful, because then you can find the equation of a tangent line, you can find the equation that's perpendicular to that, so they give it a name. For those who don't do physics and haven't seen this from last year, the line that is perpendicular to it is known as the normal line, which back in year 9 you've already found. If you know the equation of one line, normal line is perpendicular to it. But in order to do perpendicularity, there was one formula. What was the formula again? How do you check if they're perpendicular? What was the formula? Yes, very good. So negative, or it's not negative b. Oh, sorry, no, you're thinking of, you were close. You were thinking of quadratics. It was negative something though. Negative reciprocal. So, for those who weren't sure, it's this one. This is the one I was thinking of, which I mixed up with what you were saying. It's m1 times m2. If you times the two gradients, if they're perpendicular to each other, it should equal to -1. Or if you rearrange it to find m2 equals -1 over m1, which is what Krish was saying, the negative reciprocal. Okay? So in this case here, if you know this is the tangent line, and these two are meant to be perpendicular, then the gradients are the reciprocal or negative of it. So that means the normal line must be -16x plus c. Okay, so they're reciprocal gradients. That's the only difference between them. In terms of point, the perpendicular line and the tangent line both cross at 3, 9. So you can still sub 3, 9 into this equation, because when x is 3, y is 9, they should still cross at the same point. Therefore, you can find c again, and that's how you find the normal line, and that's how you find the tangent line, and that is pretty much exercise 10a. 10a is just to practice to make sure, can you find these two equations using derivative skills to get m? Once you know m1, you can find m2. Okay, so on my very first page, those are my notes. This is when they're perpendicular. This is to find the equation of a tangent line. And theoretically, normal line is just the reciprocal gradient. That's negative. So, let's practice it. Here's your last question to do for today. On the back of the page is some VCA questions for you to try. And on the very last page, 10b, I already covered this when we started chapter 9, average rate of change versus instantaneous rate. One uses 2 points, one uses 1 point. That's the only difference between it. So, really, today's lesson was just normal line and tangent line. So we go, let's practice this one. This one says normal line 3, 9. So we just did that, didn't we? Oh well, we haven't finished the question. So we know that the normal line is y equals mx plus c. We know that had to be the reciprocal gradient of the tangent. So 1 over tangent and negative. And we figured it out to be y equals -16x plus c, since tan was 6. So that means the reciprocal must be -1 on 6. Same thing, since it passes through the same point at 3, 9, we do what Arian said before, sub 3, 9 in to find c. So we should get 9 is equal to -16 times 3 plus c. This gives you -1/2 plus c equals 9. And then depending on your fraction skills at this point, add half on both sides. So you can say it's 9.5 for c. Or you could say it's what, 19 on 2. So therefore your equation for your normal line must be -16x plus 19 on 2. Okay. You can do this on a calculator as well. So if you don't know how to do it on a CAS, I'll quickly show you. There is a printed screen there for you on your notes. But here we go. This is how you do tangents and normals. Go to menu. Algebra, or calculus, sorry. Calculus, so menu 4. And if you have a look at the bottom, 9 and the letter A. So if you press 9, you will get tangent line. And if you press A, you get normal line. So if I did tangent line, function was x squared, and I wanted it at x equals to 3. because that's 3, 9. So we use the x value. This gives us the equation 6x minus 9, which is what we calculated before. Was that right? Yes, we did. 6x minus 9. And then our perpendicular one, so normal. Menu for A, you can actually press the letter A on your keyboard and it gets normal line. X squared, comma, x equals 3. And that's what we got, 19 over 2 as your y-intercept, and the gradient's negative 1 on 6. Okay? So you usually use that when it's multiple choice questions. If it's exam 1, you had to do what I just showed you, how to do it by hand. And that's it for today's lesson. It's just 10A. 10B is just revising the difference between average rate versus instantaneous rate of change. And then don't get confused with average value when you learn integration. That's about it. All right, team. So keep practicing your derivative skills because that's what leads you to be able to solve tangent lines and normal lines. I'm going to stop the video here.